Welcome to Calculus.
We've always been good at math. How hard could calculus be?
On this episode, Stevenson will demonstrate.
Find the volume of the solid generated by revolving the region about the given line. Alrighty, we have y equals x squared, there it is, y equals 0, that's just the x-axis, and x equals 2, there's the vertical line. But, we are revolving about the line x equals 2. We are revolving this way. So since we are revolving in a horizontal direction instead of a vertical direction, this is going to change how we integrate. In other words, what we're going to be integrating with respect to. So let's try to make sense of the problem here. Since I am rotating horizontally, my rectangles are now going to be horizontal. There we go. Well, what that means is that their thickness is now going to be a dy. So we're going to need to figure this out in terms of y, rewrite this in terms of y, and we're going to be integrating vertically from 0 to 4. So let's get a sketch and try to figure out, make a little more sense of what we're dealing with. Now, if I revolve around this line, it's going to be solid, so it's going to be a disc, but my cylinder essentially is going to look like this, where the axis of rotation is going through it, like that. So this is the line x equals 2. Now, what's the radius? Okay, so this is the radius, right? We need to know the radius of our cylinder. Well, the radius is going to be whatever this distance is here. So if I pick some arbitrary x value, the radius is that distance. Well, how would I find the radius is going to be the distance left over? So if from 0 to 2 is the entire distance, and I pick some x value, then that's going to create my radius of my cylinder. So I'm going to take that away. So I now know the radius of my cylinder. So what is going to be then the volume of one of these? So what's the volume of one of these slices, right? What's the volume of one cylinder? Well, remember, it's still going to be pi r squared h. In this case, though, my radius is 2 minus x, but my thickness is dy. Okay, we have a problem here. See, my differential is in terms of y, it's dy. I need my function to also be in terms of y. So we got to do some scratch work. You see this x right here? We have to make this x in terms of y. So how can we do that? Right here. So see, this x distance is attached to the x squared. So over here, we have y equals x squared. So we're going to solve for x. Now, we've done this in previous videos. So I'm going to take the square root of both sides. And I get 2 answers. So you might be thinking, well, which one do I use, Stevenson? Well, if I do this one, then I'm going to have positive y values. If I do this one, then I have negative y values. So look over on the graph. Look on the sketch over here. Which one do we have? Do we have positive y values or negative y values? Well, based on my graph, I can see I have positive y values. So what this tells me is this must be the correct one to use. So essentially, I now know x is really the square root of y. So I'm going to take this, and now I'm going to rewrite my volume of my slice. So this becomes pi times 2 minus radical y dy. Now I have my volume of my single slice ready. I'm now going to take this and rewrite the entire total of what I need. So we're going to have the total volume is going to be the integral from 0, now look vertically, 0 to 4 of all the little slices. So this is now my volume of this particular solid of revolution that it's making. Now again, it's a solid revolution because it was generated by revolving the region. And at this point, you could do this by hand, or you could go ahead and put it in your calculator if you do it by hand. So I'll give you 2 answers. I'll give you the exact and the approximation.